Alright, welcome to lesson 78. We are going to be talking about classifying triangles. And let's start out here. Every lesson looks like we have a little warm-up. And so let's start by giving you a moment to work on this warm-up if you haven't already. But it's just a good way to kind of get yourself thinking and reviewing some of the previous concepts. So right here, take some time and do these warm-up problems, and then come back and I'll just mention a few things on maybe some problem-solving strategies that might be helpful. So if you haven't done these already, pause the video, do the warm-ups, and then restart the video and we'll talk about the warm-ups. Okay, hopefully you've got the warm-ups done, and a lot of these you're just looking at addition and multiplication, subtraction, and then there's a problem-solving word problem here. So let me just mention a few things. Some of the ways that I like to tackle addition, you certainly can do it the traditional way by lining them up according to their placeholders, and you would just take 8 plus 7, which you know is 15. You're going to carry the 1, and 4 plus that 1 is 5, plus the 3 is 8, so you get 85. Another way that I like to do it actually is I add the values that are not units. In other words, the 8 and the 7, I leave those until last. And I know that the 4 and 3 really represent 40 and 30, and that gives me 70. And then the 8 plus 7 I know is 15. So then 70 and 15 give me the 85. Sometimes that actually is easier for me. I don't know why, but if you're trying to do mental math, sometimes I find that a little more, just a little easier to do. Also, when I'm doing and I'm adding numbers, sometimes I will think, what do I need in order to get that number, let's say the 8, up to 10? So I know I need to add 2 more to get 8 to 10, and I'm going to borrow that from my 7. So 8 plus 2 gives me the 10. That would make the 7 into a 5. Sometimes my brain thinks that way too. It works that way, and I think 8 plus 7 is the same as 10 plus 5. Okay? So you can approach those that way if you want. Multiplication here, 30 times 40 times 20. You are looking at powers of 10 here. So anytime you see zeros like that, that's really 3 times 10. And the 40 is really 4 times 10. And the 20 is really 2 times 10. So if you've got 3 tens, 10 times 10 times 10, that's the same thing as 1,000. So you're going to have 3 tens in your multiplication problem, means you're going to have 3 zeros at the end of your number. And then the 3 times the 4 times the 2, so 3 times 4 is 12, and then times 2 is 24. So that's 24,000. Okay? And then when you're subtracting, it helps to line up decimal points. So 0 times 0 is 0, and then here you can't take 0 minus 5, so you have to borrow from the next number over, but that's going to be another 0, so you have to borrow from this 2, make that a 1, make this a 10, borrow from the 10, that becomes a 9, that becomes a 10. So this is the traditional approach. So 10 minus 5 is going to give you 5, 9 minus 2 is 7, and 1 minus 1 is 0, so you just get 750. Another way to approach this is to think 20 minus 12.5 is going to give me some number down here. That number, if I take that number and I add it to 12.5, I would get 20. So I have to think, what do I want to add back on to 12.5 to climb back up to 20? Well, let's just take it little bits. If you take 50.5, 12.5, and you add 12, and then you add 0.5, you're going to get 13. It's like, think of money, $12.50, and you add 50 cents, you now have $13. Now 13, how much more do you need to get up to 20? You just need to add 7 more. So we added 50 cents to get from $12.50 to 13, and then you add 7 to go from 13 up to 20. So what's the total amount that we added? $7.50 got us back up to 20 from 12.5. You'll see it's kind of the same value there, okay? Or it is exactly the same value. All right, and then you can do that for this one as well. So $1.98, I'm going to get back up to 6. Oh, sorry, I'm adding this one. Sorry, this is adding. So you want to line these up. Line up your decimal places, okay? And then 6 and 8, you're going to have, again, I think in my mind, 8 plus 2 more is going to give me 10. So I borrowed those 2 from the 6, leaving 4. So 8 plus 6 is the same as 10 plus 4. So that's 14. Carry my 1. 9 plus the 1 is 10, plus the 4 is 14 again. Carry the 1. 6, 7, 8. So 844 looks like. And then Robbie is mailing an envelope that weighs 6 ounces. The postage rates are 37 cents for the first ounce and then 23 cents for each additional ounce. Okay? So he's going to give the postal clerk $2, but it's not going to cost $2. He's giving him more than what it costs because he's going to get some money back. So he has $2 bills. So 6 ounces is the total weight of his package. 37 cents for the first ounce. So 1 ounce is going to cost 37 cents. Then, of the 6, you already paid for 1. Now you're going to pay for the remaining 5 ounces, and each of those 5 ounces is 23 cents. So it'd be like taking 37 cents, and then you add 23 cents, and another 23 cents, and another 23 cents, and another 23 cents, and another 23 cents. Well, you did that 5 times. That's the same thing as 5 times 23, and 1 times 37. So if I take 5 times 23 cents, or if I add it up, that's a 23, sorry. If I add up 5 times, okay, well, that's going to be 20, 30, 40, 50, 60, 70, 80, 90, 100. So that's $1. Okay, 100 is like $1, and then I've got 3 cents, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 cents. So it's $1.15. The 5 23s gives me $1.15, and then the 37 cents. So $1, and then 15 cents, and then 37. If I add all those up, I'm going to get 2. That's 12. 5 and 7 is 12. I'm going to carry the 1, 3, 4, 5, and then add all those up. I get $1.52. You gave the guy $2, but it only cost $1.52. So how much change do you get back? Well, again, you can think about what do you need to add to get back up to $2 from the $1.52. So $2 minus $1.52. If I add 8 cents, that gets me to $1. Okay, I'm going to do it this way. I'm going to go 152, and I'm thinking, what do I need to add to get back up to $2? Because that's the difference. 2 minus 152 is the same thing as saying, what's the difference? What's the change between $2 and $1.52? So I'm thinking, what do I need to add to get back up to 2 from 152? So I'm going to add, I'm going to do it in little bits. 8 cents, because that's going to get me to 160. 1.52 plus 0.08 is going to be 1.60. And then I'm going to add also 0.40. And that's going to give me up to $2. Okay? So 152 plus 8, these two here gives me to 160, and then the 160 and the 40 gives me to $2. So the total difference here is These two numbers. 48 cents is what I get back. Okay? So I hope that's helpful. Again, we can go over that if you have any questions. All right, today's new concept is all about classifying triangles. So there are three types of triangles that they start out here, and they have to do with the angle. So they're going to define triangles based upon the angle measurement and also based upon relationships of sides. Every triangle has three angles, three sides. So they're going to use the angles and the sides to kind of name it. The triangle is going to have a name. It's just that simple. Okay? If your triangle has only one angle that is obtuse, and obtuse means that it is greater than 90 degrees, but it is less than 180 degrees. So it is less than 180 degrees. I shouldn't put an equal sign there. Sorry. Less than 180, greater than 90. It's in between 90 and 180 degrees. That is an obtuse. So this angle right here is obtuse, and therefore that triangle is called an obtuse triangle because it has one angle that is obtuse. If the triangle has an angle, one angle, so only it's going to have one, and it is a right triangle, or is a right angle, it means that the angle is exactly 90 degrees. That is called a right triangle. And if all the angles are less than 90, acute, then it is called an acute triangle. Okay? All right. Now the other way is to look at their sides. Up here we looked at the angles, obtuse, right, or acute. Another way to name a triangle is to talk about the sides. If all of the sides are equal in length, and I'm going to put a little mark on all three of them to show that they're all the same length, that is called an equilateral. Lateral means side, equal, equilateral. If only two of the sides are equal in length, these two right here, this third one is different. It is called an isosceles triangle. And if all three of the sides are different in length, that is called a scalene triangle. Now what you can do is you can combine these, meaning you could have an obtuse triangle, you named it according to its angle, and it could be scalene. So those two could go together and you could say it's an obtuse scalene, or scalene obtuse maybe. Or it could be an obtuse isosceles, or an obtuse, no, it can't be an obtuse equilateral. All right? So there are different combinations that you might be able to have here as you look at the names based upon the angles and the names based upon the sides. Okay? So here it says an example, and it says draw a triangle that is both a right triangle, this is according to the angle, and it is an isosceles. That's according to the sides. So we have to make sure, start with drawing a right triangle. So they put a right triangle, 90 degrees right there. That box in the corner tells us that 90 degrees, that it's 90 degrees, okay? Then you have to make sure that if it's isosceles, two of the sides have to be the same length. So they've drawn these two sides on either side of the 90-degree angle to be exactly the same length. I'm going to put a mark, one mark on each of those. And then once they've drawn those two sides to be the same length, they're just going to connect the ends of those two sides, and now you've got a right, okay, that's 90-degree angle, isosceles, because two sides are equal. This third side is different, okay? Doesn't have to be the same as the other two. Can a right triangle have two right angles? Well, do you know what the total sum of all the angles of a triangle are? Every triangle, doesn't matter what shape or how big or anything, every triangle, all of the angles, 1, 2, 3, angle 1, 2, 3, I'm just going to number them, okay? Always angle 1 plus 2 plus 3, these are the angles, those are not just numbers, okay? Angles 1, 2, and 3, if you add them all up, they will always equal 180 degrees. Okay? Always. So it's saying, can you have two right angles? Well, right angles are 90 degrees each. If you had two of them, you would already be at 180 degrees without even the third angle. Well, you can't do that. So a right angle there's only going to be one of them. A right triangle can only have one right angle. Okay? Practice B. What is the name of a triangle that has at least two sides equal in length? So if we look back here, it's talking about sides. So if it's talking about sides, then that means it's talking about these three names here. So if it has at least two sides equal in length, and that would be your isosceles triangle. Okay? If one side of an equilateral triangle is 4 inches long, then what is the perimeter of the triangle? Now, they only gave you one side, but they told you it's equilateral. So really, they're telling you all three sides. So all three sides are the same. 4 and 4 and 4. You have a triangle. All sides are the same, and each of the sides are 4 units, or in this case, inches in length. So to find the perimeter, perimeter is the distance around the object. If you were to walk around that object, how far did you walk? Well, you walked 4 on one side, 4 on the other, 4 on the third, so for a total of 12 inches. Okay? All right. Now, I want you to pause the video here, and you are going to work through the problem set. All 30 problems. Tackle all 30 problems, and then come back, and I'll give you some hints on some of these problems and how you can solve them. I may not solve them all completely, but I'll just give you some hints in case you got stuck, and then you can continue to work on it, and then we'll go over the questions you have. Okay? Pause, and then come back. All right, I'll just make a few comments here as we go through these 30 problems. It says Jamal bought apples at 5 cents per pound at the sale. He spent 95 cents. How many pounds of apples did Jamal buy? So 5 cents per pound. That's for each pound. He spent 95 cents. So if he only bought 1 pound, that would be 5 cents. If he bought 2, that'd be another 5 cents. 3, another 5 cents. 4, another 5 cents. So hopefully you see the pattern, right? So it's 5 cents for every pound. Well, this would tell me that you bought 4 pounds. 5 plus 5 plus 5 plus 5. This would be a total of 20 cents. And that would be for 4 pounds. Well, if you take 20 cents and you divide by 4, that gives you the 5 cents for 1 pound. That's the cost in cents per pound. So here it's saying you didn't spend just 20 cents, you actually spent 95 cents. So how many pounds is that? Just like our simple example, 20 cents got you 4 pounds. So that must mean then 95 cents if you divide by the cost per pound, which is 5 cents per pound. 95 divided by 5, you have to take 95 divided by 5, and if you want to do that, 5 goes into 9 one time. 9 minus 5 is 4. Bring down the 5. 5 goes into 45 9 times. So 19 fives give you the 95 cents. How many fives give you 95? That's what you want to figure out. So 19, so that means you bought 19 pounds of apples. Okay? Laura placed 243 paint cans on the shelf. So 243 are sitting up on the shelf. 95 of the cans fell. So you lost 95 of them. And so you're going to do a simple subtraction problem there. Okay? Hopefully that's not a problem. Pamela listened to half of a 90-minute tape. How many minutes of the tape did she hear? So 90 minutes, but you only listened to half of it. So you're going to have to take half of 90 can do it 0.5 times 90, or you can do 1/2 times 90, but you can take half of 90, whatever method you feel most comfortable, and that will tell you the minutes that she listened to. 1/4 of the guests gathered in the living room. So 1/4 of often in mathematics means multiplication. 1/4 of the guests. We don't know what the guests, don't know the number of guests, so I'm just going to put a big G there for guests, okay? Gathered in the living room. What fraction of the guests did not gather in the living room? Or what percent of the guests did not gather in the living room? So, fractions of a unit, fractions of something, always add up to 1. Just like percentages of a unit of something always add up to 100. So 1/4, these are some things that you probably should just know, you should just memorize. 1/4 is 25%, because 1 divided by 4 is 0.25, and then that is 25 hundredths. 25 hundredths, that's what percent means, 25 per 100, okay? So if 1/4 is 25%, then what's the rest of it? What's the rest of it to get 100%? Well, the rest is 75%. Or another way to say it is, how many more fourths do you need to get 1, to get a whole unit? You have 1/4, so you need another 3/4. Because 25% and 75% give you 100%, just like 1/4 and 3/4 add up to 4/4, which is 1. So fractions of a unit always add up to 1. Percents of a unit always add up to 100. So it says you've got 1/4 of the guests are in the living room, so that means the remaining 3/4 are not, and that fraction is 75%. Okay, 3 divided by 4 is 0.75. You can do the long division if you want, and that means 75 hundredths. 75 per 100. Okay. One side of an equilateral triangle is 3 centimeters. If they give you one side of an equilateral, you got all 3 of them. So equilateral triangle, 3, 3, and 3. And what is its perimeter in centimeters? So this is in centimeters. So we just have to have 3 plus 3 plus 3. That's a total of 9 centimeters. And then you want to change that to millimeters. 9 centimeters. And I hope you've done unit multipliers. For every 1 centimeter, that is 10 millimeters. Okay?
All students and parents will need to vacate the building at this time unless you are in a meeting.
Okay, so sorry about that interruption. 9 centimeters. There are 10 millimeters in every 1 centimeter. Okay? So if we've got 9 centimeters, notice what I'm doing here. I'm taking 9 times 10 millimeters over 1 centimeter. The reason for that is I want the centimeters to cancel. I know for every 1 centimeter, there are 10 millimeters. This is what's called a unit multiplier because those two values are the same. So 9 times 10 is going to give me 90 millimeters. Okay? Those are my two answers. Which of these arrows could be pointing to 2,750? Well, here's 2,000. So right in the middle is going to be 2,500. And so it looks like this would be closest to 2,750. Okay? Half of a gallon is a half gallon. So a half gallon means half of a gallon. Half of a half gallon is a quart. So half of a half, that's actually a quarter. 1/2 times 1/2 is 1/4. So half of a quart is a pint. So if I take another half, okay, so I did first a half of a gallon, then I did half of a half, and now I'm doing half of a half of a half. That's 1/8. 2 times 2 times 2 in the denominator, 1/8. 1 times 1 times 1 in the numerator. And that's a pint. And then half of a pint is a cup. So half of a half of a half of a half. And that's 1/16. So that means a cup is 1/16 of a gallon. There are 16 cups in a gallon. And they want to know what fraction is it of a quart. Well, this was half gallon. This was your quart. Notice it's called a quart because this is a quarter, right? And then this is a pint, and this is a cup. So right here you'll notice that a quart is a quarter, whereas a cup is a 16th. Look what we did here. We have a half times a half, which is right there, but then we multiply by another half times a half. So this is another quarter. So here you've got this is your quart, and then we multiplied it by another quarter to get your cup. So a cup is 1/4 of a quart. Okay? Isabel weighed 3 kilograms when she was born. 3 kg. How many grams is that? Well, there are 1,000 grams in 1 kilogram. Notice the way I'm writing my unit multiplier. I want kilograms to cancel. So I want my kilograms in my unit multiplier to be in the denominator. So I know I'd take 3 times 1,000. 3,000 grams. Estimate the product. Well, I'm going to round this to 400. So 400 times 7, I'm just going to take 4 times 7 and then add 2 zeros at the end. 4 times 7 is 28, so that's going to be approximately 2,800. Okay? It is afternoon. What time was it 12 hours ago? Well, 12 hours ago, if we back up 12, so this is 5 right now. Okay, if we back up 12, so it's going to be every 12 hours you go, for example, it's almost, this is meaning that it's almost 5 p.m. This is close to 5 p.m. here, okay, because it says it's afternoon. So the time that it was 12 hours ago would have been in the morning. 24 hours ago means it would have been the same time but the previous day. Now you're going to do 12 hours just means if you're in the afternoon, now you're going to be in the morning the same time in the morning. So that means 5 p.m. and if you go 12 hours earlier, it's going to be 5 a.m. or close to 5 a.m. It's not exactly, it's 4:56, I guess. And now it's going to be 4:56 a.m. Okay? All right. Number 11, compare 3/4 and 4/5. Draw and shade two congruent rectangles to show the comparison. Oh, that's interesting. Huh. You'll have to show me. Maybe you can show me how you do this with the two congruent rectangles. I'll show you the way that I approach this. 3/4 and 4/5. One way to do this is to turn these into decimals and then you can compare them. So whether you do these by long division, long division or a calculator or something, 3 divided by 4 is 0.75, 4 divided by 5 is 0.8, and now immediately I can see that 0.8 is bigger than 0.75. Okay? If you don't know how to do that, here's another trick, is you can take the denominator from the one fraction and multiply it by the numerator of the other. 5 times 3 is 15, and the denominator of the one times the numerator of the other. 4 times 4 is 16, and now whichever side is bigger, 16 is bigger than 15, and that tells me that the one on this side is bigger than the 3/4 on the other side. Okay? All right, I'm going to let you work through all of these, 12, 13, 15, 14, 16, 17, 18, 21, 20, 19. I'll mention something right here. Make sure you do square root before you divide. So make sure you find the square root before you divide there. Okay? And remember that dividing is the same thing as multiplying by the reciprocal. So for example, yeah, I'll just get you started here. 970 divided by the square root of 25. The square root of 25 is 5, and dividing by 5 is the same as multiplying by its reciprocal, which is 1/5. Okay? So you can think of it that way, or 970 divided by 5. Okay? Lots of ways to approach it. And I'll let you do 22, 23, 24, and you let me know if you have any questions on those. 25. This is 8. Every single equation. This is an equation, and it has an unknown value in it. Every single equation is going to ask you a question, and you've got to answer the question. So it's like a mystery, a riddle. 8 times something equals 120. 8 times when the variable is written right next to the number, then it means multiplication. So 8 times some number is equal to 120. Well, the way you can figure that out is 8 times what equals 120? You can think of it as undoing that multiplication. If you want to figure out what 8 times something is to give you 120, then you are going to divide both sides by that 8, because multiplication and division undo each other. So divide by 8, that means you have to divide the other side by 8. 8 divided by 8 gives you 1. 1n is what you want to figure out. And so that n is going to equal 120 divided by 8, and you need to figure that out. Okay? Here, f times something is equal to 108. You always have to do exponent first. 3 squared means 3 times 3, which is 9, equals 108. Then you need to divide both sides by 9, and f is equal to 108 divided by 9. You figure that out. Okay? All right, 27. You want to add all of these numbers so that you have all of those numbers added up plus the n. So n plus something equals 54. So all of these numbers, when you add all these numbers up, that's going to go right in there. And then if something plus that number is equal to 54, then you're going to subtract. Let's go ahead and do this here. So 7 and 3 is 10, that's 12, plus 8, that's 20, plus 5 and 4, that's 29, plus the 7, that's 36. Now I'm going to subtract 36. Why am I subtracting? Because here I'm adding 36, so if I want to get rid of adding 36, I will undo that by doing the inverse operation, which is subtraction. So then I subtract over here. Adding 36, subtracting 36 just leaves me with the n. And then 54 minus 36, you figure that out. And again, in my head, I'm thinking, what do I have to add on to 36 to get back up to 54? Well, I add 4 to get to 40, and then 10 to get to 50, and another 4 to get to 54. So 4, 10, and 4, that is 18. Okay? Find the perimeter and the area. Perimeter is the distance around. So 8 plus 4 plus 8 plus 4. And that will give you how many units. How many steps does it take you to go around that object? Area is how many squares does it take to fill up the surface. And each square is going to be whatever the units are, 1 unit by 1 unit. So if you'll notice it, you have 8 that go the length of it and 4 that go across. So that's going to be basically 4 rows of 8. 4 times 8. and that's going to tell you the area, and it's always in squares. How many squares? We represent that by saying units with a 2, units squared. Okay? All right, name the transformation that would move this triangle to position WXY. It looks like it's a reflection, if I'm not mistaken, but you can correct me if I'm wrong. It looks like this basically got reflected like this. So A got flipped over to W, B got flipped over to X, C got flipped over to Y, and it's almost like a mirror image, as if this line right here was a mirror. I think that's called a reflection, but you can let me know. And number 30, the first 4 multiples of 18 are 18, 36, 50. So you're counting by 18. 18, you add another 18, you get 36. You add 18 to 36, you get 54. You add 18 to 54, you get 72. What are the first 4 multiples of 180? Well, 180, you always start with that number. Then you have to add 180 to 180, and that would be 360. I added 180, and then I'm going to add another 180. So 360 plus 180, that's going to be 460 plus 80. That's going to give me 540. And then you're going to add another 180. 180. So 540 plus 100, that's 640, plus 80 is going to give me 640. That gives me 720, I believe. Okay? So those are your 3 multiples, or the four multiples for 180. So I know I went through that kind of fast, so you need to let me know when we talk if there's something that you didn't understand on that, either when you went through it on your own or when I talked about it. Maybe there's something that was confusing, okay? And we'll talk and clear up any confusion that you had. All right? All right. Let's work together, and let's keep pressing forward, and hopefully we can keep working and improve on our math. Okay? All right.